Now we have design, IP, and simulation coming together.
Today, let's focus on transformation in automotive industry.
The vehicle is basically a computer on wheels.
Hey Jayraj, welcome to Pune. Welcome to Ansys. Hello Jayraj, welcome back to Pune. It's always a pleasure to host you.
Thank you for having me, Amit. It's always a pleasure to come to Pune.
Now that we are part of Synopsys family, how do you feel, Jayraj?
Super excited. For the first time now we have design, IP, and simulation coming together. And it gives us the opportunity to re-engineer the way products are engineered. As our CEO Sachin mentioned, intelligent systems of today and product innovations of today are powered by silicon. They are software defined and infused with AI. So our tools, our capabilities actually help enable a transformation where we can design, optimize, and virtualize not just a component, but the entire holistic system.
In our last Fireside Chat, you spoke about transformation in semiconductor industry. Today, let's focus on transformation in automotive industry, especially since you spoke recently at JSAE conference. Can you throw more light about what are the trends which are shaping the future of mobility?
Very, very interesting things happening in the automotive sector. Of course, it's going through major transformation. The product development lifecycle itself is shrinking. You have to get new models out, new derivatives out sooner. So the time to market is shrinking. Complexity is going up. Your cost pressures are always there. Despite that, I think the four major trends that I see in the industry at working with customers is around electromobility. So you have EVs everywhere. So it brings a new set of complexities and challenges associated with EVs. You have ADAS and autonomy that is very popular. You need sensors and capabilities to get you to a place safely. Autonomy is really getting more and more attention in the industry, especially in context of all the different compute capabilities that are coming in. The car itself is software defined. The entire car is software defined. So the ability to introduce features, to navigate and provide a better user experience, all of that is done through software. In addition, the vehicle itself is transformed. You have material engineering, you have the structures, you have better designs and better models coming to market. So in a sense, all four major vectors around electromobility, ADAS, autonomy, your software-defined vehicle, and the vehicle engineering aspects are changing.
As the automotive industry is ramping up on electrification, how do you think automotive companies are managing the trade-offs between performance, range, cost, and sustainability in their product design?
It's a very complex challenge, right? And they're trying to meet customers' expectations. Customers' expectation on range, the battery capacity, all that is going up. The complexity of the system is also increasing, right? You have to simulate all the scenarios in which this EV is going to operate in. So that means you have to consider the capabilities of the motor. You have to consider all the software that's running it, as well as the entire battery management system, right? To do that in different operating context of temperature, environmental factors, you have to simulate. So the industry is doing a good job. There's a lot of new leaders in the leader pack of the OEMs, but you'll see a lot more transformation in this sector.
As the automotive industry is shifting towards software-defined approach, what changes are you seeing in the vehicle architecture?
The vehicle is basically a computer on wheels. If you look at all the various capabilities, the features of the vehicle that are initiated using software, it's most of it, right? And especially ADAS and autonomy related use cases, the infotainment and user experience within the vehicle use cases, all of them are software driven. So all the software actually needs a piece of silicon, as mentioned, silicon powered to run. Now the silicon itself has got to have all the ability to run the various use cases. So bespoke silicon with respect to automotive sector is a big play. Most of these automotive silicon semiconductor companies are making bespoke chips that have CPU, GPU, NPU capabilities in them, and also, logic and microcontrollers that can do other vehicle and car related capabilities. So overall, the vehicle is getting more and more complex, but it is a big computer on wheels.
As the automotive industry is moving from L1 to L5 autonomy levels, the system complexity and the regulatory requirements are growing. In your opinion, how is the landscape changing for autonomy and ADAS?
It's getting really, really good. Actually, all the sensors, be it radar or LiDAR or cameras-based subsystems, they seem to be performing really well. There are companies whose vehicles from L1 to L3 is doing extremely well, and then there are some companies that have produced vehicles that are doing really well in L5. So the ability to bring these, it's actually a system of systems play. The ability to simulate the operating environment in which these vehicles are working helps bring better autonomy and autonomous systems into play.
Any key takeaways for the audience, Jayraj?
Of course, simulation engineering and digital engineering will be at the core of this transformation for the automotive sector. I'm super, super excited about the possibilities, and the automotive sector does have a very bright future.
It has been very interesting discussion. I can't wait for our next fireside chat.
Thank you, Amit. I always love coming to Pune. And last time when I came, it was at the beginning of the mango season, and now it's the very tail end of it. I'm loving it.